Hello everyone. Now let us look at the first algorithm that we are going to discuss here. The first question, or you can say the algorithm says, write a C program given an array A of n numbers and the number x. Determine whether or not there exist two elements in S whose sum is exactly equal to x. But the constraint is you have to do it in order of n time. What they are asking is, assume that we have an array like this. This is an array which is having some numbers like 0, 4, 2, -2, 9, 6, 11 and 10. Assume we are having some numbers like this. Now they are asking, in this particular array, if I want to find a sum which is, let us say, x is equal to 12. Now does this sum exist or not? And you have to find that whether any two numbers exist there or not whose sum is equal to x is equal to 12. Now you have to solve this problem. Again, to solve this particular problem there can be many algorithms which exist, and you know this is one of the very easiest problem that you are going to solve in case of algorithms. Now we are going to discuss and check all those possible algorithms which exist, and accordingly we will try to find out which of the following algorithm or which of the algorithms that we are going to discuss is better as compared to the other algorithms. Okay, now let me just do one thing. Let me just check out write down the first algorithm, that the proposed solution that you can try to apply to solve this particular problem. So the first solution, that we may call it as a naive approach. Naive approach, that is any person who just started programming and he's going to try that approach because it is one of the easiest one algorithm that can exist. So what can be that particular naive algorithm? Assume that we have this array. So what we are going to do is, let me just draw this again here for simplicity. So the numbers are 0, 4, 2, -2, 9, 6, 11 and 10. These are the elements that are present inside this array. Now in case of naive algorithm, what we are going to do is we are going to take two variables I and j. Now we are going to add all the data which is present in both the locations, which is I and j. So what we are going to do is we are going to see what is, if this array is A, so what is the data present in AI plus what is the data present in AJ, and we are going to check whether this is equivalent to the number x or not. If it is not equivalent, then we are going to increment j until we find the solution, and if after that j cannot find the solution, then we are going to increment the value of I. What do I mean to say about this? What do I mean with this? Let us say x is equal to 12. So we are going to do 0 plus 4 whether it is equivalent to 12 or not. As you can see, 0 plus 4 is not equivalent to 12. Then we are going to increment the value of j and j will come here. Now again we are going to check 0 plus 2, is it equal to 12 or not? Again we know it is not equal, so we are going to increment the value of j. So 0 plus of -2, again it is not equivalent to 12. Again increment the value of j. 0 plus 9 is not 12. 0 plus 6 is not 12. 0 plus 11 is not 12. 0 plus 10 is not 12. Now as soon as j reached the last index location, and if we cannot find the number, so what can be the next step? So next step will be increment the value of I. So the next phase we are going to increment the value of I. So now I will point to this location. Again you have to make j point to the next location as compared to this. Now again check 4 plus 2, is equal to 12? No. 4 plus of -2, is it equal to 12? No. Again 4 plus 9 is equal to 12? No. 4 plus 6, is it equal to 12? No. 4 plus 11, is it equal to 12? No. 4 plus 10, is it equal to 12? No. Again if we cannot find the number, then we can again increment the value of I. So next time I will point to this location, which is this 2. Okay, again take j. Okay, so let me just rub it up for clarity purposes. Now again you can see our I is pointing to this location So j will point to this location. Again compare the values. So you can see the sum is not equal. Then again add these two numbers, the sum is not equal, again add to these two numbers, again sum is not equal, add these two numbers, sum is not equal, and so on. Actually in the last case I think I should point to this and j should point to this, sorry. So in the last case I think we missed this step, that I should point to this and j should point to this. Now 2 plus or minus 2 is not equal to 12, 2 plus 9 is not equal to 12, 2 plus 6 is not equal to 12, 2 plus 11 is not equal to 12, and 2 plus 10 is equal to 12. So we can say that yes, at this index location, two numbers exist whose sum is equal to 12. But what is the biggest problem with this particular naive algorithm is that it is order of n square time. As you can see, when you are going to apply or implement this naive algorithm, then you will find out the time complexity for this will be order of n square. Now in the upcoming videos I'm again going to apply this naive algorithm. I'm going to write a program on this naive algorithm, and then I'm going to compare the other programs in terms of time complexities also. But you will see that this is one of the easiest approach that you can apply, and you can stop as soon as you find one sum. I mean, you don't have to find more than one numbers. You can just find out if there exist two numbers or not whose sum equal to 12. If there does not exist, then you can clearly say that it does not exist. Okay, now what can be the second solution to solve this problem? This is the naive solution, as you know, and it is one of the easiest solution that may exist to solve this problem. Now let me propose a more efficient solution to solve this problem. Again, as I told you that there may be many different types of algorithms which can exist to solve the same problem, but we need to find an algorithm which is the most efficient one as compared to any other algorithm. So the first algorithm that we wrote, which is a naive algorithm, so the first algorithm, which is a naive algorithm, and this naive algorithm took order of n square time. Now let us try to write a second algorithm, which is, let us say, name it algorithm as maybe XYZ algorithm, some new algorithm. Okay, now in this algorithm what I'm going to do is I'm going to sort this data. So sort all these numbers. After sorting, the numbers that you are going to get are -2, 0, 2, 4, 6, 9, 11 and 10. After sorting, in this second approach, we are going to apply two variables. This is the first variable, which is I, and we are going to use the second variable, which is j. What does I and j mean? What we are going to do is we are going to check a of I plus a of j. That means we are going to add these and these two numbers. If these two numbers is equal to number x, then we can say yes, the sum of this number exists. But if, let us say, a of I plus a of j is less than x, that means the sum is less than x, then we are going to increment I, and again we are going to check exactly the same solution. Else if a of I plus a of j is greater than x, that means if the sum of this number and this number is greater than x, in that case we are going to decrement the value of j. That means we are going to decrement I plus j, j will be j minus minus. What do I mean by that? Now let us say that we want to find the number x is equal to 12. Now first is -2 plus 10 is actually less than 12, because that is going to be 8. Therefore, if this sum is less than 12, then you are going to increment the value of I. Now again check the sum. So we have 0 plus 10, which is less than 12, hence increment the value of I. So it is going to be 2 plus 10, which is equal to 12. Hence we are going to stop here. Now what if we find a number which is actually greater than that? Then again we can decrement the value of j. Now you can find out, now this algorithm is actually a much better approach as compared to the previous one, because in case of naive algorithm it took order of n squared time. Now let us formally write down this algorithm, and we are going to write more algorithms comparatively, but I'm writing this algorithm because this again is a much interesting solution as compared to the previous one. So the first algorithm that we talked is the naive algorithm. Naive algorithm took order of n square time, and this is second algorithm. Let us say it was XYZ algorithm, and let us find out what will be the time complexity of this particular algorithm. So the step 1 that we have taken was sort the array in non-decreasing order. As you know, what is the difference between non-decreasing and increasing order, as well as decreasing and non-increasing order. You know what is the difference between all these four. So first algorithm says sort the array in non-decreasing order. Now you know there are so many different sorting algorithms that are present, and let us say we are going to apply randomized quick sort. So this function or this particular thing can be done in its order of n log n time. So it is going to take order of n log n time. Now if you see this loop, this initialization is going to take order of 1 time, and if you see this loop, this entire loop, it is going to run order of n time. Therefore the time complexity will be order of n log n plus order of 1 plus order of n, which is going to be order of n log n. So the second approach that we implemented here is going to take order of n log n time. So it will be order of n log n time complexity. Now as we found out that first approach was order of n square time, the second approach was order of n log n time. Now does there exist a third approach which can solve this problem in order of n time? As you know that the first problem says that you have to solve the first one says that you have to solve this entire problem in order of n time. We found out an algorithm, the first algorithm, which is going to solve this at order of n square time. The second algorithm that we found out is going to solve this at order of n log n time, but we needed a solution which is going to solve this problem is order of n time. Now question is, does there exist a solution which can solve this problem in order of n time? This is very interesting. This is very interesting. And the answer is yes, there exists an algorithm. How we are going to do it? For this, the hint is you are going to apply hashing. Now in the next video, let us look at the algorithm which is hashing, how you are going to solve exactly the same problem with the help of hashing. Okay. Now let us move on to the next video where we are going to solve this exactly the same problem in order of n time, and then I'm going to apply all these three approaches in terms of program, and I'll show you in the exact running time, if you take larger number, which program will take less time. Okay.